Okay, so for let's look at question 3.1, right? So by considering the form of a cosine theta plus b sine theta equals to r cos theta minus alpha, we need to show that r is equals to square root a square plus b square, and alpha is tangent inverse b over a. So basically, this is just proving for us to look at the using addition formula to derive the r formula. So let's begin. Okay, so if we start by looking at r cos theta minus alpha, right, we know that looking at this, right, we can use the addition formula, right, for cosine. So r cosine theta minus alpha, right, this is the same. If I were to use to expand this is r multiplied by cosine a cosine theta cosine alpha is cos a cos b plus sine a sine b, right? And supposedly this is the same as r cos theta cosine alpha. Let me just erase that. Let me just arrange cosine alpha cosine theta plus r sine alpha sine theta. Okay, and if we compare this, right, to a cos theta plus b sine theta, right, if supposedly that they are equal as what we see here, then we can by comparing coefficient, you can see that a would be r cos alpha and b would be r sine alpha. Okay, so from here, right, what do we do next? Okay, so we can assume this, right, basically your a is r cosine alpha and b is r sine alpha, and we can call them equation 1 and equation 2. Okay, so then if we were to just square equation 1 and equation 2 and we add them together, this gives us a square plus b square, which is basically the same as adding r cos alpha, r cos r sine alpha together. So r cos alpha square plus r sine alpha square, right? This is the same as r cosine plus r square sine square alpha, which is the same as r square cosine square alpha plus sine square alpha. And you know that cos square plus sine square, this is just equals to 1, which means that our final answer just turned out to be r square, right? So from there, you can see that actually, if you equate these two, right, this tells you that r is basically the square root of a square plus b square. Okay, now similarly, if we were to take from here and we assume to just take equation 2 divide by equation 1, this gives us like b over a, which is the same as r sine alpha divided by r cosine alpha, cancelling r top and bottom. Sine over cosine is the same as tangent alpha, right? So this helps us to also assume that tangent alpha is the same as b over a, and therefore alpha is the same as tangent inverse b over a, right? So from here, you have actually been able to prove what the question wants us to do, to show that r is square root a square plus b square and alpha is tangent inverse b over a. Okay, thank you.